Good morning and welcome to Make Up Repair. Today, for your delighting edification, I have a device on the bench for hopeful repair. Now, I don't know if I'm going to be able to. I have actually seen this specific device up and running briefly before it kind of went all unstable and stopped working. So that would indicate a power supply problem. What is this? Well, it looks like an oscilloscope, doesn't it? And it's listed as an oscilloscope, but it's a little bit different. So I would probably describe this as more as a scientific piece of equipment rather than an electronics piece of equipment. It has very limited bandwidth, for example. So in the 1 volt to 40 volt range, it's 30 kilohertz. Below that, it's 160 kilohertz. So that's hardly anything. But let's take a look at the time base over here. So here's the time base. So the fastest thing on the time base is 1 microsecond. The important thing to realize is that this doesn't say time per division. This is time per point, because this is a digital storage solution, and the fastest it can do is 1 million points per second, which isn't very many, of course. Over here is 1 point every 2 seconds. Now the storage of this is 4K, so that is a lot of seconds. In fact, let's just take a look at that and divide it by 3,600 seconds in an hour. This is 9.48 days for one trace. So that's why I'm describing this as more of a scientific piece of instrumentation rather than an electronic piece of instrumentation. Quite useful. In fact, yeah, I might even keep it because, you know, that would be quite handy for just grabbing, let's say, some temperature readings or something like that. What else is different about this? Obviously, this storage, and it can take some bubble storage in the back, and I don't think, no, it hasn't got the bubble storage unit in it. The bubble storage only stores 5 traces, so it's not really worth writing home about. Obviously, we've got various playback controls over here. We've got numerics, grids, data movements, subtractions, cursor movements, whether you want XY display or Y time or a rolling display. So it's, you know, quite interesting from that point of view. And then we've got 2 channels, channel A, channel B, but they are differential channels. These are differential input signals, not single input signals. So there's 4 BNCs for 2 channels. So obviously, if you want to use it in single end mode, you just ground one of the sides of the differential. But yeah, so there we go. So this is the plus side, this is the minus side. So yeah, your differential signal goes on there. So yeah, overall an interesting piece of kit. It would be really nice to see this up and running. Okay, so we've got a fan running. We've got live. It's lit up. I'm not entirely sure if that's clear on the video. I might just turn a bit of the lighting off just to see if we can make it a bit more contrasty. And then we've got a line. So that's not bad as a starter for 10. I'm not sure if you probably can't see on the screen, but there is actually, you can see a little bit of noise where this was plugged in. And the traces running across the screen. Let's get this plugged in, and this is 4 volt peak to peak 1 kilohertz, so that should be alright, shouldn't it? And let me just have a look. So I am looking at channel A in DC. So this definitely works. That's a XY display. This is a Y time display. Oh, and there we go. I just heard something go. Very strange. The display is gone. It's actually over on the right side now. Yeah, maybe. Trigger is no longer triggering. These lights aren't working. So yeah, we've definitely got something gone wrong there at that point. So there we go. I do actually still have a single little spot in the middle, essentially non-responsive to anything. So I guess I'm most hopeful that this could just be a power problem. And the reason I'm thinking that is that the fan kind of dipped as the first of the problems presented itself. So anyway, this doesn't look too hard to get into. That's quite concerning. That was really, really loose. Cool, and we're in. Now, service manuals. This is the total of the documentation I found, one sheet, and basically it's a list of the specifications, which, you know, is useful enough when I get to that, if I get to that. Let's have a bit of a survey around. Things aren't looking too bad. I mean, this appears to be the power connector, just running into the main logic board. We've got an Intel processor here, an 8253 U3441. We've got some cable connectors here that are running off board. A few calibration trimmers and things around, quite a lot in fact. I was kind of hoping that some of these might be marked with what they are, etc., but it looks a bit limited. There's no function listed for each of these, for example. Just useful words like header, switch, con. What are these pots up here? SD5000N. That's a bit 74LS logic. We've got some interesting networks up here. I'm assuming these are divider networks. And up here we've got Nicolet data assembly. More 74 logic. Some are socketed, some are not. Generally speaking, most of it's bog standard logic. Up here it looks like we've got a few op amps, CA3140. Seems to be the device of choice. Through that. Whoa. Okay, I've just found the other half of it. So these are, I'm assuming, are the operating system EPROMs. These are interesting. This is obviously well, this is marked char, so I'm assuming that's for characters. So I'm assuming this is the character generator section of it, and there's an MC242 AP up there, which I don't know its part number off the top of my head, but I'm going to guess that's what it is. And then there's a whole load of these AM 2901 CDCs. Who knows? These look like the analog to digital converters. There being two channels, of course. And the channel inputs are going where? Okay, the channel inputs are going through the B and C connectors up onto this top board into this section just here. I'm very concerned that I might actually end up just taking off the back panel just so I can get access. I don't normally like doing that because it kind of causes a bit of a problem with the integrity of the whole thing while you're working on it, but yeah, okay, sometimes you've got to do what you've got to do. Cool, finally. This out. Another one goes inside here somewhere. Okay, and we are separate. I'm just having a look to see on here whether there's anything useful like voltages printed. There's the word power supply. I'm not feeling wildly excited by that. The capacitors, these capacitors at least, look depressingly flat and untroubled. So I'm actually looking at details that are printed right on this bottom board. See if we can zoom in for just a second, just so we can show you that. So yeah, I'm a bit out of focus there, but below that white line there, so there's your plus minus 5 return, which is a pin, comes up onto the board, up to this white wire which goes down to ground. There's a plus 5 next to it which is connected to nothing, and here's another plus 5 DC which is connected through to the red. I've got coming from the other end, so the blacks all go to the common, which obviously makes sense. The reds go to the plus 5 volt, the yellows go to plus V, and the blues go to minus volt DC. Again, no indication what that voltage is meant to be. Okay, so on ESR, thank you very much. So 209 microfarads, 0.13 ohms ESR. So no problem there. 216 microfarads and 0.14 ohms. So again, pretty happy with that. Can't complain about that really. So 85C, 200 volt, 200 microfarad. They're looking good. Bugger. So blue, minus 15. Red, 5.189. Write these down. Blue, minus 19. Wasn't that minus 15 a minute ago? Oh, look at that. It looks like blue is creeping away. Yellow is doing exactly the same as the blue. It's creeping away in the opposite direction. So I don't know what this voltage should be. I'm going to guess it's either plus minus 15 or plus minus 18. It's obviously tracking positively and negatively. So we know it's 23 volts, minus 23 volts. Alright, it's actually a few days since I shot the first part of this video, and I'm just coming back now to do some more. I was just taking apart some of the components off this board because I'm having a bit of trouble tracing through exactly where the fault is. So I decided I would take a few components off, particularly around here, some capacitors and things like that were in the way, so that I can reverse engineer it just a little bit. And I made the very sage comment that it's really important to be careful when you're taking these sorts of components off, because you can't really get replacements. What the hell are you going to... This is a transformer. A PCG B7023 AC10099. Where the hell are you going to get one of these from if you break it? And literally, I had no more than said the comment, then I broke the foot off one of these, a leg off one of these. I did search for a spare, and no, none was to be found. So yeah, that was a bit of a disaster. And then I found this. So I eventually, after looking for quite a while, found a brand new one. I say brand new. So I'm hoping, this being new old stock, that I'm pretty much going to drop this in and it will work. Now I will have to be a little bit cautious of a few things. So on the original that's in there, there's a bit of stuff on these coils to stop them vibrating, so I'll probably repeat that. So I think this one is hardwired for a specific voltage. You can see the wire links in here. Whereas this one, the links are missing, and they actually go back to a bunch of switches over on the other side. So that's okay. I think we can probably deal with that. Now the other end has this board on it, which also houses a suppressor. So we'll obviously have to desolder this little riser board just here and solder it onto the new one, but there doesn't seem to be any configuration as far as I can see. Now there are a couple of differences. Yeah, this new board is slightly more populated than the old one. So as I recall, for example, I think there was a minus 5 volt supply that could be provided but wasn't on this board. And we can see there should be a capacitor down here, and there should be a coil just here, and a resistor, and some more diodes, and they all appear to be fitted actually on this board. So yeah, that's quite interesting. I don't see it really affecting its value though. There's, you know, they're just not used. So I'm going to connect this. When I connect this to the mains, I'm going to wind it up quite slowly. I'll put a variable voltage on the input and just wind it up slowly from about 50 volts until we reach 240. Okay, so this is our new board in place. I'm getting 5 volts out of it. I'm not getting plus minus 15. So yellow should be 15 and it is just under 1. Here's my 5 volts. Now I do need to trim that up to about more like 5.1. That's because obviously there will be voltage loss. But there'll be some voltage loss as we go down onto the main board. Okay, blue should be minus 15 and it's about minus 1. Okay, so we need to remember that this is not under load at the moment. So if I have a little probe around, so this is the output from this transformer just here. So we're kind of expecting that we've got pulses going into it, and yeah, so I reckon that's the 5 volt. So the reason we've only got occasional little spikes is because we've got no load attached to this. Suppose I could attach a load and just see if that changes a bit. Okay, we'll turn that on. So I'm just drawing 100 milliamps here at the moment. Yeah, there we go. So we've got much better switching going on there now. Let's just come down there. There we go. Yeah, so you can see the switching going on a lot better there. That's on the 5 volt line. Let's have a look at the higher voltages. There's our higher voltage, so everything is switching absolutely fine coming up the front end of this circuit. I've got no concerns about that. So all of that circuit right the way through there appears to be working. Oh, 10.1 volts minus 10. Excellent. I'm going to increase this to 200 milliamps. .3 volts. So why is it that our two power supplies are behaving somewhat differently? Our old one, we know there's a fault on that, which cuts out after a while, but when it's not cut out, we can measure the voltages. We get 5 volts regulated, and then we get a sort of growing, ever-growing voltage on the plus minus volt DC, and those are unspecified voltages, but guessing they're around, it's supposed to be around about 15 volts, but they just grow forever. Now on the newer one, what happens is we get our 5 volts DC regulated, absolutely fine, but the plus minus volts DC unspecified amount is less than a volt. So, you know, something is happening somewhat different there. Now, when I put it under load, the new one works. It gives us an expected type of voltage, and it's stable and set, and everything is absolutely fine. So what is the difference? Well, it's a really tiny difference, and it caught me out for a little while. So I've made this sketch, and this is the old one, and this is what I was working from all the way through, really. So all we've got is we've got a primary switching side over on the left here, and that goes into a transformer in the normal way. And here we've got our output coils for our different output voltages. So we've got a 5 volt one down at the bottom, and this is just a center tapped output. And we've got 2 diodes to get the positive side of the waveform out, and they go through a little choke and into a capacitor and charges it up, and that's fine. We've got a positive voltage out. Now to regulate that feeds back through to a 555 timer, which has got a trimmer on it, so it's acting as a threshold essentially, and enables, disables the primary switching function. So once we're at 5 volts, it disables the primary switching, we don't get any more pulses, we don't get any more voltage. As the voltage drops off, then the 555 threshold is no longer met, the primary switching is re-enabled, and we start getting some pulses through. Absolutely fine. not a problem at all. Somewhat simplistic design, but it kind of works. And we see our 5 volt regulation happening absolutely fine. Now, notice there is no bleed resistor or anything like that on this capacitor on the 5 volt side, so it tends to kind of hang around at 5 volts. It's losing a little bit of current through the feedback to the 555 timer, and a teensy bit through its own internal losses, and a teensy bit through to the multimeter, but that's it. So most of the time, once that's reached 5 volts, the primary switching is not really pulsing very often, and we saw that on the scope. If we translate that across onto the higher voltage outputs, which we're saying nominally are about 15 volts, then we've got exactly the same diagram. We've just got more coils in the transformer, so we just get a higher voltage out into these diodes through the same sort of choke and into the same sort of capacitor. Yeah, it's not really surprising then, since there's no bleed resistor or anything like that on here, that this voltage continues just to rise, because there's nothing taking the energy out of this capacitor. So it will continue to go up until it reaches whatever the maximum output is from this transformer. And it's just getting these little blips of high energy, storing them, then getting the next blip, store it, next blip, store it. And so the voltage there just rises up bit by bit. So the difference on the new one, which I hadn't spotted, is a single resistor right here. So there's one of those on the plus volts DC, one on the minus volts DC, and one on the minus 5 volts, and there is not one on the 5 volt plus DC side, because that's the regulated actual output. So the 5 volt is exactly the same as you just described, and the higher voltage, let's say our 15 nominal volts, has this bleed resistor on it now. So we get our pulse of power, which is really, really tiny, coming through. It gets stored and it gets bled away almost immediately. So this never has a chance to rise. And that bleed resistor is what's making the voltage stable when we actually apply some load to 5 volts DC. Now, I have subsequently looked at this in circuit, and this is about 600-700 milliamps on the 5 volt side, and that gives us about 14.4 volts on the plus and minus volt DC outputs. So that's pretty good, but also it fools me. I will admit to being caught out by the fact I didn't spot that there was now a bleed resistor in this circuit. So anyway, let's go back and fit the new board into the device and see if it works. Alright, let's get this reassembled. Alright, we're assembled as far as that goes. Now, there's actually something that I need to do here, which is that I really need to deal with this very, very badly bent item here. So we can see the frame underneath is bent slightly, just slightly awkward. Because I want to get in here. This is bent further up. It's got a bracket that connects across to the CRT shield. So as far as I can see, the handle has been really badly compressed inwards. It's kind of been pushed in, I think. Because I'm pretty sure these corners shouldn't be here, and bent here as well, unevenly on the two different sides. I need to deal with this problem to begin with. This is of course under tension. I'm hoping the other side will come off easier once this tension is released. Okay, cool. Come on out. Okay, so we can now see the kind of damage that we've got here. So in some ways it's not too difficult. Right, I'm going to take these in the metalworking shop and see what I can do. Before I do that, you can measure the actual distance. So I'll make that 35. Alright, I've straightened this as much as I can. I've decided not to bother repainting it. Now I just need to make sure I know which way is up and down. This is the top. And my handle needs to go so it can go underneath. So it forms a stand, I believe. Well, so far so good. The handle is pretty straight and seems to line up reasonably well. tube reassembled, that's that reassembled. Let's get this bracket redone. Might need some adjustment in a second or two because... Okay, let's reassemble the back. Oh, there it is all of a sudden. Oh, right, okay, let's see what we think we need to attach this with. I don't like to cinch them up till I've got them all in. Okay, cool. So I think I'm going to just pop, I think it's these screws, one of these in, just to hold things in place while I make a start. He plugs in there. Okay, well that was quite a bit of hassle. I pretty much have to reassemble the whole thing in order to get everything secured enough to operate this safely. Okay, the fans wound up and we've got a line. This is good news, and we've got text at the bottom. Reasonably clear. I think the text at the bottom is perhaps not quite as clear as the actual line, but it's pretty damn good overall. Let's get a signal input to this. I'm on storage at the moment. Switch to live. Yes. Perfect. So this is all down to the analog digital conversion. So it's saying it can sample up to plus minus 2 volts, which will be a range of 4 volts in total. Blinking heck. So if I store that, well, yeah, I can actually move around 2 cursors now. The grid is turned off. And we can find at the bottom there, as close as possible to minus 979 millivolts, or minus, possibly a bit higher. Yeah, it's about minus 1 volt. Let's move up to the top. Yeah, and about plus 1 volt. So plus minus 1 volt, absolutely spot on. And what happens now, if I turn auto center on, then as I sweep the time, the horizontal cursor lines up. Superb. So that's working perfectly as far as I can see. My storage worked, my live worked. Switch back to live. Yeah, and actually the cursor is now moving the signal relative to the trigger point. So that's fine. So that's channel A. Let's look in channel B. So live. Channel B is okay. Channel A is off. So channel B is up at the top. So I should be able to just move that down. Okay, that's. Just to channel A on. So I can move channel A up and down using this. This is like a very fine control. Then I press it and I can move it around a lot. So that's fine. But this one, I can actually see it moving up and down a little bit right at the top of the screen there. That's when it's fine adjust. And it feels like it's kind of not stopping at the stop. It feels rough as it runs off the end. And the fine move isn't working either. Oh, yes it is, there it is. Let's give it a signal anyway. Channel B. I'll just turn channel B on, I think. Yeah, okay, and I'm triggering on channel A, am I? Yeah. So there you go. So you can actually see that channel B is working. It's just offset, and that's just this control here, unfortunately. Dodgy pot. Okay. The differential inputs look like they're working absolutely fine. Now these kind of coming together. So the only problem I can really find with it, change my times. Yep, those are changing. Sample rates are changing absolutely fine. I'm not going to test them all. Horizontal expansion seems to work. Vertical expansion seems to work. Okay, all of that seems to work okay. Roll, I think that works, so it's hard to tell. X, Y, that looks correct. If I turn B off, and yeah, there's an X, Y cross, so that's fine. So I'd have to conclude that this is working perfectly apart from this pot. And I would say that the text is not quite as crisp as I would like it, but I'm probably not going to tackle that. Anyway, this pot is the critical thing. So the pot is mounted on the top board and should theoretically be easy to get at, but I've looked at taking the bottom board out just to get access. Can't do that, so I'm having to take apart the whole thing pretty much, because on the bottom of the board are further connectors going through to the front panel, and I just can't get at those to reassemble it when the time comes. So all has to be taken apart just to get it one pot. Now all I've got to do is get the right pot off, the one that just goes around endlessly. I can just get in there. So I've seen a few people commenting about these switches here, these multi-layer switches, which are also custom built with stackable wafers, about the difficulty of cleaning them. I'm not sure that that necessarily is the case, because these come apart by crimping these two. You have to twist these metal lugs so that it'll slide off, and then you crimp these little, they're almost like plastic rivets, and that should withdraw then and enable all the wafers to fall apart. But of course you've got to do that carefully, because otherwise things are a mess. But fortunately I think we're okay, we don't need to clean those. Could do as a matter of course, but yeah, let's leave alone what isn't broken, I think. So I'm giving these a bit of time, a bit of a wiggle, and a bit of time to warm up, in the hope that I draw the solder out cleanly. There it is. Hooray! Alright then, let's take a look at this. So I have spent a few minutes looking around to see if I could possibly get one, and the answer is absolutely not. So I'm going to have to take this apart. There are long rivets starting on this side, and they progress all the way through. So there we go. Hopefully we can see on the back. Here's the front. So there's a rivet there, one in each 4 corner, passing all the way through the segments. So you can see there's a 1K segment, spacer segment, and another 10K segment on the back. Those pass all the way through, and they kind of are splayed out on the back here. So I think the easiest is going to be for me to literally take those into the workshop and just drill them. So this is the kind of bush. So I've separated out the spacer. So I mean, basically the design is here's the back piece. There's some metal plates on the back to hold it all together, but there's the back piece that comes off. Then we've just got a spacer, and this has got, you know, this is perfectly intact. There's nothing wrong with this at all. It turns absolutely fine. It reaches its end stop, and that's it. It's absolutely fine. This then is the front section, and on the front of this we've got this metal bush, and on the inside of that we've got our spring and a kind of plasticky thing. What I've done here is sketched a quick cross-sectional through the pot. So on the back we've got this section here, which is the 10K pot. On the front we've got the 1K pot, and passing through them is a shaft which is spring loaded. In the middle of that shaft is a bead which should be fixed tightly in place, and it kind of grips sort of, but it's sliding around a lot. Now what's supposed to happen is that this end here is where the knob goes, is when the knob is released, the spring pushes out, and this little bead here snuggles in to the front pot, the little cup that matches on the front pot. And these are both textured. They've got like little grooves cut into them, so they will kind of lock together reasonably well under the spring tension. And then when of course you turn that knob, then the bead turns because it's attached to the shaft, and the pot turns because it's got a good friction fit with the bead. When we want to move the back one, we push in, and the bead moves across and snuggles into the back pot instead of into that kind of cup in the back pot instead of the front pot. And again, it's kind of like a friction fit, and when we turn the knob, it rotates the back pot instead. So that's the design. It's very simple in principle. So I'm pretty sure our problem relates to this little plastic piece on here, which is like a friction mount that pulls spring loaded back into this bottom piece, or you push it forward and you're pressing it into the back piece. It seems to be gunged up with quite a lot of greasy stuff, so that's one problem. The other problem is it was actually sliding around on this shaft, so there was no way ever it was going to pull properly back into this back piece. So I've attempted to just glue it in place to stop it moving, because it will not friction fit anymore, that is for certain. There's not a lot of room to get activator in there to make it go off very fast, so I'm having to hold it in place and apply some pressure. Okay, so that is actually rotating the front section correctly now. So you can kind of see that the wiper is turning. So that is the spring pressure. So press it on hard and turn it, and that will appear to be turning as well. Great. Okay, so in terms of reassembling it then, I think I'm going to try and reuse these. They're quite a tight fit, and they're hollow. Kind of my feeling with it is, if I can actually get these through again, if I can get these again without injuring myself, they will actually hold in quite well in their own right. And I think what I might be able to do is actually just epoxy them on the back, because they're hollow. Just want to make sure that this is absolutely clean before I attempt to. So I've forced the little things through the back, and what I'm doing now is I'm trying to just make sure that I fill the hole. Got to get epoxy resin into that hole. It's not good enough just to wipe it on the back. This is a 5-minute set in epoxy resin, so I have to work quite quick. Now, another method is I could have actually glued the 3 segments together, but then we would never have been able to do any repair in the future. Using this epoxy can always be scraped off and removed, if worse comes to worse. And I'm just going to use the tips on these slightly bent tweezers to make sure that I've introduced the epoxy fully into each of the tubes. Pushing it in there to make sure that we haven't just ended up with it on the surface. We should be there. Alright, let's just let it dry. Now, I haven't fastened this piece on the back. I could do that. This is the piece that was sold to the board to give it physical connection. The reason I haven't done that is because those pins are actually slightly shortened now, so they won't go through this properly, so I was afraid that I wouldn't get a very good physical connection. And in fairness, I think we've already got sufficient, and we've already got a metal back plate on it. I think it's sufficient to hold it together, and there are already front tabs on the device to hold it onto the board, plus 6 through-hole connectors, so you know, I've just had enough with that. I think that's fine. So despite the fact that despite the fact that this is probably set now, I'm actually going to leave it a full 24 hours to fully cure before I attempt to put it back on the board, and then we'll find out whether or not we've been successful. Okay, so we're up and running. I've got a sine wave fed into A and a square wave fed into B. I'm just going to reduce the frequency a bit. 500 Hertz, that'll do. And I'm triggering on B. Now, these 2 output frequencies are symmetrical from my function generator, which is why they're both stable. But it's triggering on B. There's this nice square wave, slightly rounded corners as you'd expect. Yeah, and that's absolutely fine. And let's just check I've got my offsets the right way around. So this is a DC, that's set to DC. So negative, positive. Yeah, there we go. We can see as I move the DC offset more negative. I'm just going to move that to 0, so that is zeroed. And we can trim this one up to the centre, hopefully, a bit more towards the centre at least. There we go. That's on B. So on B, I've got this signal here, which is a slope. So I'm going to put this in XY mode now. Okay, maybe I needed YX, but anyway. So X obviously needs to be this signal. And we should have it's this one, isn't it? There's our sine waveform, and that's tracing out the length of this thing. So if I increase the volts peak to peak on here, yeah, there we go. This is our XY display. So yeah, I'm pretty happy with that, I think. And this guy will be the one to move it around. Excellent. Yeah, we can expand. Expand vertically. Cool. We can put it in memory. Yeah, and move cursors around on it. It's probably very difficult for you to see that on the screen. There's a vertical cursor and there's a horizontal cursor marking out the, so I can move the horizontal cursor basically. This button here enables me to choose horizontal cursor tracks the vertical cursor. Roll is just giving us a constant rolling signal. That is normal Y versus time. Well, I think it's time to put all the knobs back on. Now I do need to take a little look at the power supply again, because I'm getting a couple of false starts here where it kind of starts up and then fails, and I suspect that there's a current setting on the power supply, and what's happening is we're getting too much like a surge current through, and that is that's triggering the power supply to shut down. I suspect that's what's happening, don't know for certain. It'd be nice as well if the on-off light would illuminate, but that's probably a neon. I'll see if I've got one. I think that's come out pretty nicely. It's pretty clean. I mean, there's the inevitable scuff on the main body. The front panel is cleaned up nicely. The knobs are cleaned up nicely. These are cleaned up nicely as well, the BNCs. So I've adjusted the power supply, so fingers crossed. So A isn't triggering at the moment, which makes sense. Let's turn some stuff on. I'm grounded. AC, there we go. Okay, let's turn on channel B. So there is channel B at the bottom at the moment. We'll move it up. Turn on channel B and I should have a signal at a different frequency, which I do. And if I modify channel B now, waveform, let's have a ramp. There we go. If I turn off channel A, we can see now channel B. If I trigger on channel B, it should become stable. Excellent. So if I store that, I should now be able to move. I've got auto center on, so I can see that currently the cursor is set on the left hand side and it says 776 millivolts. If I scroll that across to the peak, 1.302 or thereabouts, then I can kind of move this up. I can move it faster if I multi-click it. There we go, and it's kind of locked itself on the bottom, minus 2.646, 1.318. So add those two together and you should get about 4. Great. So if I change the frequency now, nothing happens because I'm on store. If I switch back to live, there's my new frequency. Cool. Now, of course, in practice, it doesn't go very high frequency-wise because this is, I think, 4,096 samples, and this is the sample speed, and it's it's a million samples a second. Well, you know, that doesn't give a lot of space, does it? Or does it? So let's move up to 10 kilohertz. And you can see it's getting a bit tricky. Let's try some horizontal expansion though. That's absolutely fine now. We can see it's made of its individual dots. So let's go up to 20 kilohertz. Now, I can't remember the bandwidth of this, but it's not very much, to be perfectly honest. But there we go. There's our 20 kilohertz signal all sampled, and now it's stored. Now this is doing some sort of, if I switch this up to save, it's doing some sort of sample and store type stuff simultaneously. I really don't get it. Okay, so here it is, the completely repaired Nicolet 3091. This has been quite a challenging repair. The power supply was a bit unexpected, so that uses primary side regulation for the 5 volts, and the higher voltages, the plus minus higher voltages used for the op amps and things like that, are allowed to just float around. They actually turn out to be running at about 14.3 volts, maybe 14.4, and then on the boards where they're used there is separate plus minus 12 volt regulation for that. I didn't really know that as I set off. I've got no circuit diagrams, I haven't even got an instruction book. I've got a specification sheet, and yeah, so that was a little bit challenging to fault find, and I did have a little bit of a cock up on there, and I ended up putting a new power supply board in, which I also wasn't quite sure was working until I understood that the voltage output on the plus minus volt is dependent upon the amount of current you're drawing out the 5 volts. So once I started drawing about 600-700 milliamps out the 5 volts, the other voltages came up, they behaved themselves, and all was well. I also had a bit of a problem with the power supply in that it has a adjustable current cutoff, and this was cutting off sometimes when it started up, and I think that's just because of the initial surge charging the capacitors and things like that. So I've managed to find that and adjust it, so that seems to be stable now. It starts every time. There was a problem with the pot on channel B, the vertical offset pot, which is a very weird custom built device, and I looked at a replacement for that. I found a company that would do it, but it would actually cost me more to buy that one pot than to basically just, you know, the entire value of the device. So in the end I took the pot apart, found out how it worked, and effected a repair on it. Hopefully that repair will work well and last for a very, very long time. There's obviously another one here that potentially could go wrong, and there's actually another one of them at the back which is slightly different configuration but similar, so that could potentially be taken apart for spares if needs be. Okay, anyway, it's all up and running now. I'm going to actually sell this on eBay. I kind of like to keep some of these more interesting older bits of test equipment, but in practice I just don't have room for them, unfortunately. I'd really like to do so. This one's in pretty good condition as well. There's the usual few scuffs and things on the case, but the front panel is pretty much immaculate, really. Finally succeeded. Seemed to take forever because I had to order some parts for, well, the power supply in fact had to come from the US, and that took quite a few weeks. And in the meantime I'd kind of forgot what I was doing, but it's done, it's together. Hope you enjoyed it. If you did, please, of course, you know, thumbs up, and don't forget to subscribe. See you next time. Bye for now.